Hi, welcome back to Spring CS170. Before we get into Chapter 8, which is the second of two chapters we're covering for week 2, I just wanted to remind on some admin. So you have this home page that if you sign on the Canvas for Spring CS170, this is where you'll land. So just a reminder, here's all of the different resources for the class, but if you want to just look at one page, you can just go into My Sections here. It says Allow sections 16 to 26. You click on that. I try my best to put everything in here. If there's something in here that I've missed, make sure someone lets me know. Why is this taking so long? Yeah, so here we go. So it comes up. So this link right here, you can bookmark it, you can save it or whatever, and then you'll come in here and notice you'll see on the left hand side you can get to these things too. Um, so as I said in my other video, all this stuff here covers everything that you need in a class, and then down here is week by week for the videos, plus I also put in the resources. So you see last week I put in the resources, which goes to the modules area for week 1 resources. It talks about what you should review in the textbook and some knowledge questions for your own self-study. Here's week 2, same thing. And then here's the base conversion worksheets. And so really, like I said, for chapter 7, it's really just a mechanical type of thing. These base conversions things, once you get it down, just prepare to do that for the exam. Okay, and there's a couple angles to try to do these in the quote unquote easiest way. Whatever works for you is fine. I look at this. This is a very good example because there's going to be a lot of times where you're going to be doing a decimal to a hex conversion or a decimal to binary conversion. And remember what I was saying, going between binary and hex, all you have to do is follow that mapping. And speaking of that, let me come back to the spreadsheet I had last time. So remember, here's the hex binary mapping, and I did my VLOOKUP off of this. Right here, VLOOKUP, I looked at one of these, and I got the mapping. So that's all. I just did this as automate. I don't expect you to run an Excel sheet to do this, right? I just did this to visualize because my handwriting is not so good. So you can look at this when you go to the exam. Just have this table handy, right? And be able to do that mapping. Okay, so you look at one, and then you get the other, or vice versa. You look at this. Remember, if it's a long binary, break it up into chunks of 4 and do that conversion. Okay, and just practice a couple and just verify that you have that down. Right, so that's a binary to hex. Here, you remember last time I had a little bit of a bug, and the reason why I had that is because I did just a straight up division where actually I needed to do a round down right here. So then this is the right answer. So whatever I put into here, it should be, you know, whatever the right answer would be here. Okay, so it'll populate this as your way of doing it. Now, I kind of think doing this to this, I just kind of did this so you can kind of understand like how this remainders kind of works. If you just don't really want to understand how to do it and just want to follow a formula, right, and just kind of just crank it, just understand this, right? 72 to hex, 72 to binary, and just follow exactly this. And remember what I was saying here. You have it lined up like this, and it just falls to the right, right? So this will go down, so on and so forth, all the way across. Uh, let me put the 72 back here again. Okay. So 1001 000. So 1001 100. I left off the initial 0 here. Okay. So I think the one thing that would be notable also is going the other way. So let's say I have this as the binary here, right? And there's an example here too. To go in reverse, all you have to do is make sure you know all of these. right? So 2, 4, 8, 16, 32, 64, 128, 256. And then you line up your numbers, your binary number to that, and then you add them together, okay? Um, so that's basically how you want to go about doing it, right? So you see the 1 lined up to the 64 and the 1 lined up to the 8, right? So 64 plus 8 equals to 72. Okay, so I hope that makes sense. So that's how you go in reverse. If I give you a binary number, just line it up to this 2 to the exponent, and then just add them together. Okay, wherever you see a 1, just add them together like that. Okay, so get some practice with that. That's really chapter 7, right? There's a little bit about the metadata thing too, but for the most part, it's just a mechanical thing. I know in prior classes I've seen this, like, people kind of get hung up a little bit on the conversion. So you just want to kind of get whatever algorithm you're going to use to do the conversion, get that down pat, and to be able to do that fairly quickly. Hopefully that's the quickest way to do it. Okay. If you have questions on it, I'm sure the TAs are going to spend a lot of time on doing the conversions for you, with you. So lab hours or office hours or whatever, we can go over some more. We have the worksheets. I'm sure they're all going to share with you video links of different people covering how to do these base conversions. Okay. All right. So let me not spend too much more time on that. Let me close that up. Let's get into chapter 8 for a second here. So here we are, chapter 8. So this is not really mechanical. This goes back to just understanding various concepts. So I'm gonna probably have to chop this up into maybe 3 videos. Okay, but here's all the things, teaching points you should try to understand these terms, and it's also going to be covered in the reading also. Okay. So when you think about this, you're thinking about, well, we can record sounds, we have pictures, we have video. Okay, so that's what we're talking about in terms of storing things digitally. Okay, so when you look at a picture, there's this idea of all the different variations of colors is going to be some combination of red, green, and blue, right? From a computer representation standpoint. Um, so we'll get into that, like how that is actually stored digitally. But just understand, like, there's this idea of pixels, well, right here, and they each represent a color, a certain degree of red, green, or blue, and then they all combine together to get any number of different types of color combinations. Okay, so that's what this is saying here. Bullet point 2, a combination of the 3 colored lights, and black is the absence of light, which means like. So let's say you have a red, green, and blue. You have 3 points there, or 3 pixels. Um, you would put 0, 0, 0, and that would give you a black color. Okay, uh, and then white is what they consider the full intensity of each color, which would be a 1. Right, so it's 1, 1, 1 for each pixel combination. Right, there's 3 pixels. Right, 1, 2, 3. Um, so, and then you can use a byte. Remember what we were saying, a byte is a combination of the individual bits, right? So, um, so if there's a single pixel consisting of 3 bytes, remember a byte is 8 bits, right? That means you're talking about 24 bits for a color. Right? Remember, a color is red, green, and blue, 3 pixels. Each one is a byte, so it's 3 times 8 bits equals to 24 bits, right? And that's where you get 24 bits down here. So 2 to the 24 bits gives you, let's just say, over 16 million colors, possible colors, various shades of that. Okay, so just try to understand how all these things hang together, right? A pixel is like kind of like the lowest or smallest unit, and from a color standpoint. And then you need to combine three of them, red, green, and blue, to come up with, you know, these various shades of colors, right? And then black and white, right? Black is all zeros across, white is all ones across, okay? And then each of these pixels is a byte. And remember from the last video, a byte is 8 bits, right? And then that's why you end up with 24 bits, 3 times 8, okay? So 2 to the 24 gives you that many possible colors, okay? So we're gonna piece that together. And so here's a photo, right? And a photo, as it relates to a video, you can think of a video as just a whole bunch of photos strung together, right? So if you ever see those things where you have a whole bunch of pages with like some picture, and then you kind of flip through the pages really quick, that kind of makes sort of like an animation. That's how you kind of think about photos. So we start off with photos here, and the idea with video is just makes it an extra dimension, okay? So let's say this photo here is sort of like an X and Y component to it. You say it's 479 pixels by 332 pixels. So you multiply those two together to get the total number of pixels, right? So the X times Y, right? To get the area of that rectangle, right? So that's how you look at this in terms of getting the total number of pixels that make up a page, a photo in this case. And then, as I said before, each one's red, green, and blue, which is represented by 3 numbers, right? So here it's saying 51, 153, 255. That's for each color, okay? And then remember we were saying each pixel has 24 bits, right? And that gets you to this if you multiply by here, right? See this 159 up here, right? That was for the total photo here. This is the bits times 3 colors. So for each one of those color combinations times however many pixels gives you that many bits to make up this whole picture here, okay? So if there's any questions about how you calculate it, how many bits made up this picture, just try to run through this again and see if you can understand that concept there. Okay. Remember what I said before, black is the absence of light, so that means it's zeros all the way across. Okay. And whereas the opposite, white, is the full intensity of color, so it's ones all the way across. Okay. And remember for decimals, that translates into 255. Okay. And then this is the hex representation. Okay. So it's asking you the question here. You can probably kind of guess because we actually already color coded red, green, and blue here. What does this mean here, right? So 0 means there's no red. 0 here means there's no blue. This means full-on green, okay? So red, green, blue, it was conveniently color-coded for you. So when I put the max intensity of this gives you a green color, okay? So, you know, once you have things in a digital format as opposed to in the old days in terms of analog, you can do a lot of things on the computer, right? You already see that on your phone, right? So on your phone, you have any number of things you can do to put special effects on the pictures that you take. And it's gotten more sophisticated or elaborate over time. So how do they work with those things, right? They don't work with the picture like you and I would, right? Maybe in the old days, you would have some film and you would have a photographer do some special effects, and they're actually looking at the image as a human would look at that image uh, to increase the contrast or whatever, right? Um, but a computer obviously doesn't do that. A computer will store everything as zeros and ones. Okay, so there will be different strategies to do these different types of things here, like the red eye removal, photo corrections and whatnot, right? So they'll look for patterns to identify like sets of these zeros and ones to do something, right? So the first thing we would look at is the brightness and the contrast, okay? Um, so let's say like this is like really dark or something like that, right? So you might say, well, okay, I want to make everything brighter. So I'm going to apply what I'll call a shift to make everything brighter, okay? Versus contrast. Contrast is to kind of draw like a starker difference between like the bright and the dark, right? Um, so let's see what that means here. Okay, so remember, uh, dark, black, absence of light, white, more intense light. Okay, so let's say we do what I call a shift, right? Add 14 to each pixel, right? So here's the original picture. You add 14 to each pixel, right? So you have this red, green, blue. Let's say it's 195, right? Across the board. Um, you're going to add 14 to each of these, so you make it more intense. That's like a constant shift across each of these pixels, and then you end up with something like this. Okay, um, and likewise, you have like this is like presumably a darker color, right? Because you see it's a lower number here, and then you also add 14 to it, and you would make that a lighter thing. So it's uniform across all the different pixels. You're going to apply a uniform shift of 14 to it, and that's how you get to something like this. So that's one way to manipulate an image or a picture, right? So from a computer standpoint, all it's doing is doing some math, right? It's just adding 14 to each of these. So now remember what I said about the contrast. The contrast is not just a straight adding to every single pixel. That's a pretty straightforward formula, I guess, right? But to kind of make the light versus the dark a little bit sharper, okay? So, um, it's sort of like a curve. You don't add the same thing to each one, okay? Um, so here's the key idea here. So for the dark pixels, you actually want to kind of keep them somewhat dark, right? So maybe you add a small amount to the darker one, but then for the lighter ones, you're going to add more, right? So that you're making the spread between the dark and the light bigger, right? And that's contrast. To make things lighter or darker, you just constant all the way across, brighter, darker. For contrast, you're looking at a starker difference between the dark and the light. Okay, so like I said, smaller amount for the dark pixel, larger amount for the light pixels creates a sharper contrast. That's why they call it contrast, right? So what does that mean? So here we identified the darkest pixel in the picture. That's at 38. And the lightest pixel in the picture is at 239. Okay. So here you can see they apply like a shift for like the high range here. Okay. And then here you can see like a pretty small shift, right? Relatively speaking to this, right? And that's what they did to increase the contrast, okay? Um, in this case, they just kind of put the numbers in here, but if you kind of look at it, you can apply sort of like a formula to it, okay? So you can categorize, you can pick a range, right? So you can say, okay, all the pixels that are in a high number range, or like a middle range, or a low range, you're going to apply a certain type of shift to it. Okay, red, green, blue, right? So anything that's kind of dark, like the smaller numbers, will be here. The middle will be here, and then the highs would be here. And then you put on a custom shift here, right? So it's a little bit more sophisticated than where you just say, okay, I want to make everything brighter, and then have a constant shift across everything. So you identify different parts of the picture uh, and assign them into high, middle, or low, and then apply the appropriate shift to it. Okay, so let me stop here, and we're gonna continue on with more multimedia digitization. Okay, thank you.